Welcome to another video in the LaTeX tutorials, a comprehensive series. In this video, we will talk about chapter 8 of the book, which is on chemistry. How to write various chemical relations, bondings, and all the relevant material to chemistry. To facilitate chemistry writing and sketches in LaTeX, we will have to use this package, which is actually the chemfig. So it is to be added in the preamble. We start with a /document class, and here we select A4 paper and 12 point, and the class is a book. Now we will paste our chemfig package, and then we will start with a begin document and end document will come automatically. Okay, now our content will be started here. So let's go here, and in order to show a bond between two atoms like A and B, we will have to use this command, which is chemfig AB. And I just paste this and I build it, and here it is. It has written AB. So let me maximize this in order to be clearly visible. Similarly, this one to be visible. And here it is AB. Now we can mark here to the next command. For double bond, we will have to write chemfig and then A equals B. So this will give /chemfig and then the curly brackets, and here I write A equals B, A double bond B, and now I build it, and it is A double bond B. So I place enter here, and it will be on a new line, and this is equal to AB. Similarly, the other commands, like for a triple bond, we will have to write the approximate symbol, which is just below the escape key, is noted on the keyboard, and it is copy, and I enter this and paste, and this will give triple bond, and here's the triple bond. So the bondings can be done with these commands. Similarly, the different wedges, whether solo, holo, dash, they can be done with this command, like chemfig and less than symbol, and then and is written. So in this and we can write any text, and here chemfig greater, so it will create a solid wedge. Similarly, for holo wedge, we will have to write the vertical sign with it, and then it will create a holo wedge. And for wedge dash, we will have to write a colon with this thing. So by executing these commands, we can have these outputs. So they are clearly mentioned in the book and they can be followed. Now in section 8.1, we can cover the bond angles. The bond angles can be covered in the whole range from 0 to 360 degrees, and between the two atoms or more than two atoms. So for example, if I want to mark a bond at an angle 30 between A and B, then I will have to write this command chemfig, then this is the as usual A dash B, but now with respect to B I will write this additional command, and this is in square brackets colon 30, and then it means that to the A, the bond to the B will be at 30 degree from the horizontal line. This is the horizontal line, so it will be at 30 degree, and the output will be like this. So let me copy this command. We can write this command as well and paste it. So here I execute this, and I can see that it has made an angle between A and B at 30 degree. Similarly, if I want to make this angle at minus 30, like A here and B here are in this image, so I will have to write minus 30. So from the horizontal line it will come down at 30 degree. So if I put minus here, mean minus should be in front of the number and not in front of the column. So here I will write minus, so it will just convert this into minus, and here is the minus 30 degree, and here it is. Now it is minus 30 degree. Similarly, a complex structure which is to be understood, like in the case of double angle command, for example for water molecule, we know that the H is bonded with O and then that O is bonded with H. So to understand this command, we will have to, the usual command will be there, that there will be a bond between H and O and then O and H. So it is H and O here, and then bond between O and H. But the angles are to be understood. So the very first thing, hydrogen here is bonded at 52.24 degree with oxygen. So let's look here, hydrogen here. So if I consider this as the horizontal line, then at 52.24 degree this is bonded with oxygen, and then oxygen is then bonded, this is oxygen, and this is then bonded with hydrogen at an angle of minus 104. So what I will do here, I will have to write here double colon, and double colon means that oxygen is actually possessing a bond here, another bond, and it is minus 104. So let's understand this one. If I extend this line, then from this line to the horizontal line, this angle is again, according to this angle, is 52.24, but as it is in this direction, so it will be minus 52.24. And then I will have to, from this horizontal line, if I make another horizontal line here, I will have to come till here with another minus 52.24. So combinedly from this line to this line, it is minus 104.48. So this will make my water molecule. Copy, and I paste it here, and I just run this. And it is like this, HOH. And now, in order to understand the role of double colon and single colon here, if I remove the double colon from here and I just mark this one, then here you can see that our OH has been converted to this form, which is not right. So the first angle, it is to be noted that the double colon means the first angle we are counting from the horizontal line here, and then the next angle is from O, not from H. So due to that reason, we will have to mark here double colon. So mark here double colon, and then it will be right. For more than 3 atoms, the simple angle command will be extended as the command for writing CCl4. Now here, let me briefly discuss this one as well. We are making angles with carbon. So carbon is bonded with chlorine, again with chlorine, and on all 4 sides. So if I consider this as the horizontal line, then carbon is bonded with chlorine at 0 angle. So here is carbon bonded with chlorine at 0 angle. Then this carbon is also bonded, so it's in brackets, this carbon is also bonded at 90 degree with chlorine. So it is from this to this at 90 angle. And then it is again bonded at 180 degree with chlorine. So this is again with, from here to here is 180 degree. And now after this one, I mark that it is again bonded with chlorine at minus 90 degree. So I write here minus 90 degree. We will have to check this command, copy, and here I put it, and I just build this one, and here it is. It has made us chlorine C bonded with 4 chlorines. And now here, if this is 180, then what about this one? If I mark this one another, like this one at 270, if I mark this 270 and I just build this one, okay, now it has been built, so it is the same, it has not been changed. So we can write here minus 90, means we go this way, or we can write 270 counting from here. So both the way it will work. The following code produces chemfig R bonded at C at 0 angle, and then C is double bonded with O at 60 angle, and then the third one is something which is to be thought about. You look here, C is bonded with O. Now this angle bond and then minus 60. So it is which line from where this angle has been calculated? It is actually this line. If we extend this line here at this point, then we will have to go minus 60, and then it will be with oxygen. Similarly, to produce a structure like this, that slash chemfig R bonded with C at an angle of 0 degree, and then C is bonded at 60 degree with O, and then it is bonded with 60 degree but minus 60 degree with O, and after this one O is again bonded with 120. So here 120. If I look at horizontal line here from this point, then it is 60, but I will have to look from here, this horizontal line with this oxygen. So from here 90 till here, and then 30 here. So this is 120, and then carbon is bonded with R at minus 180. So look here, I am considering this. So from here this one is minus 180, or from here this is minus 180. If I give plus 180, it will come here, and then a double bond between carbon, because carbon here the parentheses are from here to here, and then here. So double bond, and this is at minus 60, from this line to this line minus 60. So this way I can make such a complex structure as well. Let me execute this command, copy, and I execute this command. And I build it, and you can see now that the structure has been designed. So after this, let's start with 7. A skeletal draw can be produced by the command, which is this one. Now we are not writing the atoms but directly the bonds. So here there is a bond which is at 30 degrees, so a horizontal line, this is at 30 degree, and then there is another bond which is at minus 30 degrees, so horizontal line here and minus 30 degree. Then there is a double bond at 30 degrees, so double bond at 30 degree, horizontal line here, and then single bond at minus 30, and then triple bond at 30. So this way we can extend the bonds or a skeletal network like this. In section 8.2, we will try to edit the bonds and the angles between them. Now if, for example, I want to make a bond between A and B and it is at 30 degree, but I would like to change this length. So this length can be changed by writing 1.5 b, and this will mean that the length of this line will be at 1.5 scale. It is actually at 1 scale, so it is from here to here, but the 0.5 is extended here. So let's see, let's mark this one. And now I build this, and it is here. The angle between A and B has increased here, so we can change this one by changing this value. Like I select 3 here, now it will become double the size of it, and you can see it has increased the bond length. So we can increase the bond length by making this way. In this example, it has been shown. In order to change the bond line, the color of it, so we will have to use this command. The bond, the angle is here, then we will write 4 commas, and after 4 commas red I will write, so it will make this thing red. Now actually there are different options in these commas which we are running by default, but the last one we are changing from the default. So we will write it red and then it will become red. Like I just execute this command. And I build, so it will make this thing like this, A with B, and the red line is there. Similarly, the width of the bond can also be increased. As here, I will write, after 4 commas, I will have to write the line width. So the line width is equal to 2 point. This one is by default 1 point and this is 2 points. So I will have to write the line width 2 point. And if I want to change the color as well as the width of it, then I will write after 4 commas red, then comma, and line width equal to 2 point. So this is to be carefully noted that the commas should be there, otherwise it will not execute properly. And here it is. So bond with increased width with a red color. Similarly, if I would like to change the bond to dashes, then I will have to write after 4 comma the dash pattern on and then 2 point. 2 point is the default value which is off and then 2 point. Sub this dash pattern 2 point and then off. So this way if I execute this command, then it will give a dash pattern. Thank you for watching this video and stay tuned for the next video.